Hi everyone, I'd like to talk a little bit about derivatives and the different types of notation we can sometimes see. So to start us off, let's take a look at one of the most common pieces of notation we'll see for derivatives. So sometimes we'll see something like y prime or f prime of x. All right, so we'll start with the function y equals x squared. It's our friendly little parabola, or sometimes it's written with function notation f of x equals x squared. Same idea. Okay, so if we wanted to find the derivative, sometimes we see that written as y prime. And we know from the power rule that y prime, or the derivative of y with respect to x, is 2x. And we'll also see, I'll just write this down, we can also see the notation f prime of x. And that means 2x, same idea. But where things get a little bit different, but interesting, is when we see the notation that looks like the following. So sometimes we'll see notation that says dy dx, or sometimes we'll see the notation df dx, or sometimes we'll even see the notation d dx of y. Let's take a look at these pieces of notation and what they're telling us. And it's really the same thing as we've just done with y prime and f prime, but it's really interesting to take a look at the different components of this. So the d up here in what looks like a numerator, that tells us to take a derivative. So I'm just going to write do the derivative. And this tells you of what to take the derivative. So you're going to take the derivative of y. And down here in the denominator, it's telling you what you're differentiating with respect to. And that'll come into play in a minute. Same thing over here, df dx means take the derivative of f with respect to x. And similarly, the last piece of notation here says take your derivative with respect to x of y. Same idea as what we've just done with y prime or f prime, but just a little bit of a different piece of notation. So you can see that come into play. Suppose I gave you a function like h of t equals, I'll make it a little bit more interesting, the square root of t plus pi squared. And I could ask you to find h prime of t. That's the same thing as finding dh dt. So I'll just write that this is equal to dh dt. Same thing. That's why they're equal. And the reason it is the same thing is because we're doing the derivative of the function h, and the derivative that we're taking the differential, that we're taking the derivative with respect to variable t. Okay. And this will come into play when we look at implicit differentiation, or if you go on to calculus, depending on your course, calculus 2 or calculus 3, you'll look at functions of more than one variable. So it becomes very important to know what variable you're differentiating with respect to. Okay, so anyways, let's do this. So I'm just going to use our new notation here, dh dt. Well, what would that be? Let's compute it. They gave me h of t equals the square root of t plus pi. Well, that's nothing other than t to the 1/2 power plus pi squared. Okay, that's our function. If I want to do the derivative, I can apply the power rule and get 1/2 t, subtract 1 off the back end, so that gives me a negative 1/2 as my exponent. And then the derivative of pi squared, don't be fooled, it's just a constant. Derivative of constants are 0, so it's like they tried to trick us with that one, but we did not fall in the trap. So our derivative, dh dt, is just equal to 1/2 t to the negative 1/2 power, or if I rewrite this, I have a 1 over 2. And then that negative exponent tells me to go down to the denominator, and I've got a square root of t down there in the denominator.